speaking to your henchman.
What a great measurement.
And
What is
the answer to
natural?
that one, tell me what you mean by sustainable.
Well, sustainable is the buzzword of the century, of the decade. And, you know, our dean my department had just named a new graduate program, Sustainable Forestry. And I said, well, Thomas, I mean, isn't that what forestry is all about? He said, but we're talking to 18-year-olds. They've got to hear that buzzword. And we're trying to attract these students. I said, man, we got students running out our ears. We don't have time to teach them all. We got to get more. We got to get the enrollment up. Wait a minute.
No.
You had a question.
Well, an observation. With water temperature bit, back there in Alabama and Georgia, there's a lot of more water there than there probably is here. It's very slow moving, and there isn't any logging, and those biotes and swamps and creeks and rivers, they move real slow, and there isn't any logging going on, so the trees overhang all of them, but the water's warmer, and there isn't any trout back there. There's bass and sunfish and bluegill and catfish.
Yep.
And you don't see any of those kind of fish out here, but something else they have back there is a lot of bugs. And whoever's making the argument out here about our warm water, I don't believe it. I think it is the food base. We don't have any food base. We don't have a lot of bugs, so we don't have any trout. I don't think it's water temperature. That's my observation.
But we have some royalty in our midst. We have salmon. Salmon are these these God-fearing animals who come in here and they run up the stream and they have their young, and then they croak, and then the little ones eat the big ones and so forth, and they recycle all those nutrients, and then a whole mass of big young'uns go out and so forth. It's an amazing cycle. It really is that. And but people become
Coastal streams. Coastal streams where the salmon,
but even
there's none that come this way.
Oh, they do. They do. They
Not
go
very.
past here during the cool water season. They run up the Willamette, McKenzie River, and so forth. There's a nice steelhead, and
In Mary's, because I've never heard of that in
in
my
Mary,
life.
no, there are some sea-run cutthroats that do go up Mary's though, and which is the smallest of the anadromous fish. But anyway, there are fish that cruise up through these rivers. They're cold water fish. It's a cold water fishery.
Right.
And they use these as connections to headwaters where they spawn during the cold weather. We have fall runs and spring runs, and they can manage, and they're not feeding when they're running. So it's an amazing animal. It really is. And it is almost something, there's something very special about them. And it's taken on kind of a life of its own that's beyond a natural thing. And the Indians had whole religions based on the salmon, the amazing salmon. And you can understand why they really thought it was something special. Let's see. You've had your finger up for a while.
Yeah, the one thing, and maybe, I know I've come in the middle of this, and I listened to your talk last November, and it seemed like you were discussing how whether you have overhanging trees and sun being blocked out, or whether you have the sun heating up the water. You also, I think you need to take into account that at night, where you don't have overhanging trees, you're also losing more, you're losing heat from the water to the sky. That's because the sky is a black body radiator.
That's right.
So it would seem like the two might balance each other out, and that's why you're not seeing much difference.
Well, let me describe a little bit what goes on in this heating picture. When the water, first of all, let's start with rainfall. When rainfall comes down over the whole landscape, almost none of it lands in the creek. And we tend to think of water as rushing and running off and that sort of thing. In this country, virtually none of the water runs off the surface. It soaks in, and then it seeps into the stream from the sides. Okay, this is not a groundwater inflow. But most people don't realize is that a huge percentage of what falls soaks into the bedrock. And the bedrock has a lot of pores in it. The Dyea sandstone of the Coast Range here, about 5% of the volume of it is pore space, which is full of water most of the time. And but it leaks out very slowly, and that provides our summer flow. And so what we have in the stream seeping in during the summer is very cold water. It's the average temperature of the winter rain, within a degree. Okay, so it comes in at 48 to 50 degrees Fahrenheit, all through the length of a stream. And as soon as it comes in, gets exposed to the air, it starts to warm. It warms very fast. It's amazing how fast the water moves. In streams, in headwater streams that are anywhere from 3 to 10 feet wide, the streams are moving about, the water moves about 1.5 miles in 24 hours. Okay, in that length of time, the water has risen from 50 degrees to about 62 degrees. So in one day, through a day-night cycle, it has gathered an awful lot of heat. And what it's doing is it's adapting to air temperature. Yeah, the sun will punch it, warm it up a little bit, but at night, so day and night, the temperature goes up and down about 2 degrees. But the fact is, it has come up 10 degrees from the time it came out of the ground, adapting to the air temperature. And the DEQ fails absolutely to acknowledge that.
So what you're saying is it's the air temperature more than radiative heat transfer that's heating up the water anyway.
I didn't get the...
You're saying that it's you might say it's convective rather than radiative heat transfer that is heating up the water. That the
Yes.
convective is the bigger
Yes,
contributor
that
than
is correct.
radiative, and I would tend to believe that.
And what's really fascinating, when you look at the water in Mary's River coming from Harris Bridge down to the Willamette River, the whole river, there's a lot of water in the Marys, and it's moving slowly. We figure it takes about 2 weeks for the water to get from Harris Bridge to the river.
Now, where's Harris Bridge?
What's what?
Where's Harris Bridge?
It's about 30 river miles from the river. And it's
From the
where
river.
the headwaters of the river comes through Blodgett and so forth. And about
Okay.
4 miles below Blodgett is a covered bridge across the river, which got taken out by the storm, by the way.
Okay.
And, but anyway, it didn't take 2 weeks to get to the river that week.
Yeah.
Yeah. But anyway, so every day, it warms 7 degrees and cools 7 degrees, the whole river. And on a cold night, well, we had 93 degrees and it went up to 76 degrees in the daytime and down to 69 degrees at night. That's, the whole cycle is above the cold water standard. Okay? It's illegal for it to do that.
Are you gonna arrest the
And-
river?
But,
Yeah, really.
but anyway,
Don't give them any ideas.
what's really interesting was that we had in late August, we had a very cold spell. It went down to 69 degrees in the daytime with full overcast, and the river warmed and cooled 7 degrees in the morning. It warmed 7 degrees in the morning and it cooled 7 degrees at night. When the radiation load was 1/3 of normal, exactly the same amplitude of the change.
Well, isn't it true when water evaporates, it's cooler?
Well, that's one of the amazing things about water is that it is what keeps our environment very uniform. There's so much heat transfer from evaporation. It takes 580 times as much water to evaporate a gram of water as it does to raise it 1 degree centigrade. That's evaporated without changing its temperature. When you boiling water on the stove, it takes 580 times as much energy to get rid of a gram of water that did to warm it that last degree. And it takes 90 times as much to thaw it from ice. So the change of state from water, from ice to water, takes 90 calories per gram, and to evaporate it takes 580 calories per gram. And so think of the stabilizing effect that demand for energy does. It gives off energy and it takes it away. And so that's what keeps the weather from becoming like the moon, where it gets hot as blazes, and on the cold side it gets cold as blazes. And a tremendous, it's an amazing factor in our environment here. The only reason we can live here.